Hey, I guess you knew this was going to happen. We've been doing surface area and volumes of the figures with regular cross-section or uniform cross-section. Now, what if they're tapered? There's some interesting shapes, like a pyramid. Oh, well, it's been a while since I've seen these. I must go to Egypt again. Uh-oh, I've never been yet. Anyway, pyramids, there they are. Here we are, a hemisphere, half a sphere. Okay, so there's an interesting body. If you were to paint something circular like that, so it's not circular, it's spherical, isn't it? It's a three-dimensional solid. That would be interesting to work out how much paint you needed. And here's a cone up here. To paint all around here, right around the thing, is pretty hard. And then again, I guess if it's an ice cream cone, you wouldn't want to paint it anyway. Oh well. And then a whole sphere here. Whole sphere. What about all these things? And what are these up here? Well, hey, by the time we get through this unit, we're going to need to have a party. So there's some conical party hats, and you can paint them if you want to. Oh, anyway, let's go down and have a look at how do we do this. All right, so pyramids. The idea is to, very much like we were doing before, like form a net, unpack the whole three-dimensional shape. Remember, a pyramid we would probably think of like this, all these pieces, and then one down that side. So there's all these triangles laid out. And it's a regular pyramid, means it's not tilting one way or the other. If you dropped a line vertically from the vertex to the base, it would be in the middle of that square base there. So it's a regular, straight-looking pyramid, if you like. And that would be the sum of all the surfaces. So that's what they're talking about here. A pyramid with a square base has 4 triangles, whereas a pyramid with a pentagonal base has 5 triangles. So pentagonal, what would that look like? 5 equal sides here. And so if you made a pyramid, can you see what they're talking about? There would be 5 rectangles around there, triangles around there, because there's one coming up from each of the 5 sides, or pentagonal base there, 5-sided. Okay, so it's a pretty easy thing to do, to think of, but the key is back up here, you've got to get the right net and then work on the areas of those individual parts. Let's go down and have a look at that calculation. So again, the system of labelling A2s, these are all A2s because the triangles are congruent or identical. They are identical triangles. So do one, you've done them all, mate. And so if we do this one over here, we'll then multiply it by 4. And show your calculation. In case you go funny with your calculation, then you still get part marks. Or we want, remember in this work, we want a complete mathematical solution. Not just the answer, but the way in which we obtained it. So this line is important. The surface area, SA, is A1 plus 4 times A2. The area A1 is length times breadth, or the area of a square, B times B is B squared. And then 4 lots of a half base times height. So there you are. There is a general formula for the surface area of a square base pyramid. Generally, I'm going to say don't memorise this. Usually in any problem, we want to see how you broke it down. Really this level here, so that you can show a good knowledge of area in your working. All right, come down and let's have a look at an example with a square base pyramid. Find the surface area as if you want to paint the surfaces. Paint the surfaces. If you did, you'd want to know how much paint, how much area to cover if you painted all the outside. So you're assuming here, of course, that you're going to paint the bottom here because you're including the base here. b squared plus 2bh is what you finally get when you add up all those areas, including the bottom. So if it's sitting on it, you're going to paint that. Be careful there. If you're painting the bottom, don't put it down back on the base before the paint's dry. Keep that in mind. Okay, so state the values and put them into the formula. I'm going to suggest that you would need at least that line, and I would like to see the line before it as b squared plus 4 times a half base times height. Just unpacking that a little so we can see, you know, there are 4 triangles. Be careful that all the units are the same. That is, if it's in centimetres, everything's in centimetres, metres and so on, stay in the same unit. So you've got centimetres squared there. All right, let's go down now and have a look at another example of a three-dimensional shape, and here we have a cone. Like we were saying, a cone upside down. You could have an ice cream on the end. That would be a harder problem. Let's not make it too hard, mate. Let's get rid of that for a minute. Okay, and anyway, you can't put an ice cream on the end. It's going to drop off. So let's stop the rubbish and just do the witch's hat as it is here at the moment. What you see on the side of the road, marking danger or something like that, or what you might wear to our party that we're going to have at the end when we celebrate finishing all of this stuff. Okay, the surface area is some of the area of the circular base here, and plus this curved surface, right around here. It's curving around, right around. You might be making a hat for a party and want to cover it in a fancy paper or something. What area of paper do you want? Now, what we usually do in a figure like this, let's just clarify this in here. We have 2 properties. We have the radius of the base, and we call this S is the slant height. The actual technical term for the height of the cone is this down here. That's the height H. But here we want the slant height. So let's look at deriving something here. Come down and let's have a look at breaking this up now. So here's the net. Here's the curved surface laid out, curved surface. And what we're going to try and do here is to work out a formula for the area of this cone, the curved surface plus the base, imagining that you're painting the bottom or something like that. Don't put it back down on its base while the paint's wet. Just remember that. Okay, so let's work with some formulas here. We want to find the area of the circular part. So that's the easy part. Down here, come down here now. The circle is pi r squared. And now the rest of this derivation here is trying to show you how to work out the area of the curved bit. Okay, well, let's have a look here. The area of the curved bit is theta 3/60. Now, theta is an angle back at the beginning here, if you like, of the fraction of the circle you've got. You've got theta 3/60 of pi s squared. Okay, what does that mean? Well, you've gone theta out of 360 worth of the whole circle. Now, if you have a radius here of s, you've got an area of a circle, s radius would be pi s squared. And you've got theta 3/60 of the whole circle. Theta 3/60 of the whole circle. But we don't want to have to measure, what's this? The slant height. We want it all in terms of the radius of the base. So we generally don't quote that. We quote this thing here, the radius of the base. So here we have theta over 360 times pi s squared. But can we get another expression for theta over 360? So we can just come down to r. This is fairly complicated derivation here. So the arc length, this length here, was 2 pi r. Because back in the original circle, the radius was that, and this is the length of the original base circumference there. Okay, so that's 2 pi r, which is, of course, a fraction, theta 3/60 of the circumference of this circle. theta 3/60th, and the circumference of this new circle, radius s, is 2 pi s. Fairly complicated stuff. So therefore we can get rid of theta over 360, divide both sides by 2 pi, and then we find that theta over 360 is r over s. So down here now, coming back here, theta over 360 is r over s, and we've been able to cancel that and say a simple formula for the curved area of the cone is pi rs. Now that one is probably worth remembering, rather than doing all this derivation. Okay, it's all to do with theta 3/60th, that portion of the circumference, because that's the angle you get when you unwrap all of this, the theta 3/60th. Okay, so this is the line I think you should try to remember. You've got the area of the base, which is a circle, pi r squared plus pi r by s. Okay, well, let's remember that one for painting our party hats. Okay, come down and let's see it in action now. Here is your cone. You need the slant height and the radius, and then we can simply say surface area is pi r squared, the area of the end, plus the area of the curved surface. You could put that in words before you put the formula if you want. Area of the base, which is a circle, plus the area of the curved surface. More explanation is better. Then putting the numbers in, it's not bad to list down the values that you're going to use and then show the substitution and then show the centimetres squared to 2 decimal places. Make sure the units are consistent. Units are the same in both measurements. That is, if you're going to use an R up here, here's the R, it's in centimetres, you must make sure the slant height is in the same units. How are you going? This isn't too hard, is it? It's a bit trickier because the solid is tapered and you've got to look at those curvy pieces or tapering pieces, whatever. Let's do a sphere. Now, unfortunately, at this level, we actually can't prove this thing that they're saying here. The surface area of a sphere is equivalent to 4 times the area of a circle of the same radius. Unfortunately, we're going to ask you to accept this, and we're not going to do a proof because the proof here needs basically a calculus approach. Here, you need to have some idea of calculus, but you won't have that idea at the moment. So the area of a sphere is 4 circles worth of area, 4 pi r squared. Okay, there are your tools for these interesting 3-dimensional solids and their surface area. Okay, come down and let's look at an actual example. Here's a sphere and the radius is 12 centimetres in centimetres, so you write down the formula, surface area of a sphere, 4 pi r squared, and then put the numbers in and put the units at the end, nicely set out, a good solution to the problem, not just the answer. Remember, we're focusing on a solution to a problem, not just an answer. As you go on in maths and problem solving, that solution is going to be very important to actually getting to the answer and showing people that the answer is valid. Okay, come on down, and it's time to look at some composite ones and just be a little bit tricky-dicky with your net there. Okay, so with your net, have a look. This is a half sphere, isn't it? It's a hemisphere. So here, it's the area of a hemisphere plus the base of the circle. Down there. And if you're putting that down like that on its base, and you've painted the base and you know its area, the area of that circle, you've painted the base, remember, let the base dry before you put it back down again. Okay, and so this is a hemisphere, it's a half the area of a sphere, therefore it's 2 pi r squared plus pi r squared, and then you could simplify that. 3 pi r squared, 2 pi lots of r squared plus another pi lots of r squared is 3 pi lots of r squared. Put the numbers in, state the answer. Watch it. This was millimetres this time. Did you see that up here? Did you see that? Okay, be careful. And coming down for part B, oh, can we sneak it in? Almost. I'll redo it here. It's like a silo, like this, for storing wheat or something, and it's got a conical top on it there. Often used to stop birds perching on the top because they slide down here, mate. Oh, they slide down here. Very hard to sit right on the top as well. It's pointy. Oops. Okay, so the area of the cone at the top, we need the area of that cone piece there, the area of the cylinder, all this here, and plus the area of the circle, if you want to look at the bit that it's sitting on. Remember, when you're painting this thing, do not stand it back up until the base is dry. Okay, so the area of the cone, the curved surface area, this bit up here is pi rs, and plus now the area of the cylinder, do you remember that before? It's a total distance around the outside of 2 pi r, and when you cut it up here, do you remember this from before? Cut it up and lay that curved surface out. This would be the circumference of the circle, and it's hi. So it's 2h high. It's 2 pi rh, and then the base is pi r squared. So you can put all the numbers in now. Be careful. Let's go back and check. Oh yeah, they were all centimetres. Look out for the tricky problem where they put one in a different unit, millimetres or whatever. You have to convert it to the same units. So you've got 560 pi, which is that to 2 decimal places. We usually, by the way, put approximately, showing that we have rounded off that answer, as pi is an irrational number. And it's got an infinite number of decimal places, so we can never represent it exactly. So when we round it off, we should really put approximately, or there's another sign, approximately like that. Or this does indicate the same thing, doesn't it? It's only accurate to 2 decimal places. So you can put both of those, approximately, and the statement of the level of accuracy that you've used in rounding this off. Are you getting happy with this? Okay. Well, I hope you are, because we've got a party at the end of this whole unit, and I want you to bring your conical hat. Okay, let's go down and practice now. First of all, there's a summary of everything that we've done. Are you in agreement with that? Okay, so here I think this line, and well, you have to put that one, are the lines to show the breakdown of the problem into a solution set. I would not put this one as your answer. I would show the idea, area of circle, curved surface, area of base, 4 triangles. That level of explanation guides someone through your solution, and that makes a complete solution. Remember, we want a solution, not just an answer in mathematics as we go on. Let's show how we did it. All right, come on down then, and here's your chance to show your stuff. Okay, so there's question 1, 2 and 3. Remember, basically with the national curriculum, we should get to the understanding questions from this work. And remember now, we're taking screen clippings from Pearson's book for the National Australian Curriculum. Okay, try and break these down. Here are your answers. Pause the presentation, have a go at those 3. I think you should have a go, plenty of practice at all of them now. And then we'll go on. Question 4. Quite a few parts in question 4. There's the first few of them. Starting to ramp it up here a bit. Have to be thinking about this curved surface here. What would it be like if you unravelled it? It'd be like a rectangle, unravelled. Think about these, making up your net. Okay, pause it, have a look. We'll just put these last 2 up more in screen there. There's G and H. Interesting one. Both of those. Okay, this one's okay, I think. The ice cream's going to stay on there, mate, because it's up the right way. That's okay. Let's go down to question 5. There's question 5. Pick some answers. Best way of doing that is to analyse the question first. Basically look at what expressions you'd be looking for. Don't guess. And then pick out the expressions from your options here. All right, pause it, keep going. We've got to get down to understanding, basically, I think, here to get some of these harder problems. There we are. Question 6 and 7. Interesting one. If you're going to plastic coat, you can't plastic coat capsules if you're going to swallow them, but coat them in gelatin. You want to know the area or the volume needed eventually. So have a look at questions 6 and 7. Answers over here, 6, 7 and 8. Oh, there's our party hats back again. That's good. We need those for the end of this unit. Okay, so hang on, we'll just go back up. Back to pyramids. Gee, I hope I get to Egypt soon, mate. This pyramid's getting a bit worn out up here. Oh well, have a go at that one. And we'll move down. Just remember the answer to 8 is up here at the end of the other two. Come on down and let's have a look at the reasoning questions, harder questions here, 9 and 10. You need to draw a diagram for these. And remember, the best way of doing problem solving in maths is to use a diagram. So you need to use a diagram. Here's some answers over here. But you need the diagram for a start. Go through carefully. New 10-pin bowling ball. Underlining things perhaps. All right. Let's go down and finish off with the harder questions here. These are for your more advanced thinkers in this work, and you need again to consider the things, to consider the problems using a diagram and putting on it all that you know about the problem, all the information. Okay, well, we're going along quite well here. I don't know whether you can think about what might be the next presentation, but I reckon it might be something to do with volumes of unusual figures or tapered figures there, tapered solids. Something very, very interesting. Okay, well, that's all for me now. I'll catch you in the next presentation. Cheers.